This video shows how to find the normal order using two different methods. This chapter of the book is called set theory, but so far we haven't dealt with any sets. In mathematics, a set is a group of objects, and in music it means a group of pitch classes. The most compact arrangement of a set, or group of pitch classes, is called the normal order. You may be wondering, what's the purpose of arranging pitches into normal order? Recall that in the analysis of tonal music, labeling a chord with a Roman numeral clarified the meaning of that group of pitches in a key, no matter the instrumentation, register, voicing, or texture. Simplifying the notes of the score into these abstract labels made it easier to visualize patterns and phrase structures, to compare that music to other pieces or to our expectations, and to communicate our discoveries to others. Similarly, in atonal music, arranging groups of pitches into their most compact form is a crucial step towards understanding how the music is put together and being able to articulate it. The first method we'll show in this video for finding normal order uses the clock face. Here's a four-note motive. The first step when putting the notes into normal order is to put them all into one octave. Circling the pitch classes on the clock face automatically does this. This clock face has been labeled with pitches to save time. For a review on how to do this, please see the text and videos on pitch class. The first note, D, is pitch class 2. The next note, F, is 5, G sharp is 8, and C sharp is 1. The next step is to find the biggest gap between numbers. We can see here that the biggest gap is between 8 and 1, so we cross out the numbers in between, moving clockwise. Now we're on to the final step. The next note after the biggest gap is the first note in normal order, pitch class 1 for us. Now we move clockwise up from there to 2, then up to 5, and finally up to 8. And so the normal order of this four-note set or tetrachord is 1, 2, 5, 8. Music theorists typically put curly brackets around sets in normal order. Another method for finding normal order uses the staff instead of the clock face. Let's return to the same motive we used for method 1. The first step is to put all the notes into one octave on the staff. Doesn't matter which note you start with using this method because we'll be repeating the lowest note at the top to ensure we've analyzed all intervals. I chose D because it was the first note of the motive. Now let's move up and find the closest pitch, which is F. Moving up again, the closest pitch is G sharp. And we change the register of that so that all the notes will fit into one octave. Finally, we have C sharp. When we're done with that, we repeat the lowest note D an octave higher. The next step is to find the largest interval or biggest gap between notes. So to do that, we have to analyze the intervals. From D to F is a minor third, F to G sharp is an augmented second, G sharp to C sharp is a perfect fourth, and C sharp to D is a minor second. The largest interval we have is the perfect fourth between G sharp and C sharp. The note after this interval, C sharp, will be the starting note in normal order. The last step is to start with this note C sharp, the one after the biggest interval, and build up in order. I changed the register of the note to make the notes fit more easily onto the staff. Remember that register doesn't matter when dealing with pitch classes. C sharp is pitch class 1, the next highest note is D, pitch class 2, followed by F, 5, and G sharp, 8. Using method 2, we found the normal order is 1, 2, 5, 8. The same answer we got with method 1. Let's look at a trickier example. Imagine you're using method 1 and have circled the pitch class numbers for a 5-note set or pentachord. Now you're searching for the biggest gap. Some sets happen to have more than one instance of the largest interval. This particular set has 3 instances of interval class 3, one between 9 and 0, one between 2 and 5, and another between 5 and 8. You might think that we're stuck here and just can't put the set in normal order. However, in these cases, normal order is decided by which arrangement results in the highest concentration of notes at the bottom. Let's start by building up after the biggest gap at letter A. The first note would be 0, or C. Moving clockwise from there, we get 2, 5, 8, and 9. I spelled pitch class 8 as G sharp arbitrarily. Remember that spelling doesn't matter in set theory. The hypothetical normal order would be 0, 2, 5, 8, 9. Option B had the biggest gap between 2 and 5, so we start with 5, or F, and then move around clockwise to 8, 9, 0, and 2. This normal order would be 5, 8, 9, 0, 2. If we look at option C, the note after the biggest gap is 8, which is G sharp or A flat. Then we move clockwise to 9, 0, 2, and 5. The normal order for option C would be 8, 9, 0, 2, 5. Looking at all three options, which has the smallest intervals at the bottom? We'll start by analyzing the intervals between the first two notes of each one. In A, it's a major second, or 2 half steps. In B, it's an augmented second, interval class 3, and in C, it's just 1 half step. Clearly, of these three choices, option C has the smallest interval at the bottom, so our normal order is 8, 9, 0, 2, 5. In this video, we showed two ways to find normal order and then looked at an extra challenging example. Normal order means that the notes are in their most compact arrangement, which you can do with either method by putting the notes into one octave, finding the biggest gap, and building up from the note after the gap.